Alright guys, so this is the explanation video for the big picture problem, part 1. I'm going to break these into different videos for each part so that if you know how to do one, you don't have to watch the whole video for that. So this is just for part 1. So we are asked to calculate the pH at the following time before the titration has started. Up here we've got sort of the information of what we started with, 25 milliliters of 0.1 molar NH3. NH3 is a weak base. And I've given you the Kb for NH3, 1.8 times 10 to the minus fifth. And then we're going to be titrating this with strong acid, so 0.1 molar HCl. Over here we have our titration curve, so it's a weak base, so as we might expect, our pH is going to start off as basic. At the equivalence point, we are going to have a slightly acidic pH, and we'll talk about that when we get to video number 3. Over here we've got the sort of chart, and the pHs that you calculate, they should match up pretty well, or exactly, rather, with this chart. So let's go ahead and do problem number 1 before the titration has started. So before the titration has started, the question that I want you guys to think about first is really just simply what is in the solution. So if we have an NH3 solution, that's it, right? That is the only thing that's going to be in that solution is NH3. So if I just tell you what's the pH of a weak base solution, that's something that we should know how to do. So NH3 plus H2O, it's going to give us NH4 plus OH minus, and I've given you the Kb of 1.8 times 10 to the minus fifth. So then our initial concentration of NH3, that's just our initial concentration of 0.100. Minus x plus x plus x, and that's really it, right? We're just going to solve this for x. And that x value works out to be 1.34 times 10 to the minus third. This x here, that minus x term, that's going to be negligible, right? And we can always do that test. If I say 0.1 minus this x value that I calculated, does that change that value? Not at all. And that's going to equal our concentration of OH minus, right? So again, when we're solving for these x values, you really got to pay attention. Is it a Ka? Is it a Kb? What am I solving for? So that's my concentration of OH minus. From that, I can solve for my pOH. So the way that I would do it. And then my pH is equal to 11.13. And that's it for part 1. And again, going back to my titration curve, at the 0 point of volume added HCl, the pH is 1.13, just like we've calculated. All right, so the next video will be for question number 2.